Hey there, junior scientists. Welcome to today's Magical Explainer. I am absolutely thrilled you're here. Today, we're going on an amazing adventure with our very curious friend, Soom. Now, Soom is just like you. He loves looking at the world around him and asking, why? Why do things work the way they do? Well, today, Soom is going on a magical journey to solve some incredible everyday science mysteries. So put on your science detective hats, get comfortable, and let's get ready to explore.
Okay, let's dive into this map of mysteries. First up, we'll discover the secret of twinkling stars. Second, how to escape a smoky room. Third, how ships stay afloat. Fourth, why we blink. And finally, we'll wrap it all up with the big science quiz. Let's hit the road.
Mystery number 1. Why do stars twinkle?
Picture this. Sam is lying in the grass, just gazing up at the flickering night sky. But then, he magically zooms way up, right past the clouds, completely through Earth's atmosphere and out into space. And guess what? He makes a shocking discovery. The stars? They don't twinkle at all. They're just steady, shining lights. So, science detectives, I gotta ask you, why do stars twinkle down here on Earth, but completely stop twinkling in space? Well, Sam dives back down toward Earth and realizes the secret is actually in Earth's invisible layers. See, the air isn't empty. It's made of constantly shifting layers of warm and cool air.
And this brings us to a super important science word, refraction. Refraction is really just a fancy way of saying the bending of light. Imagine you're looking at a shiny coin at the bottom of a wobbly, shifting swimming pool. The water's moving all around, so the coin looks like it's kind of changing shape and wiggling, right? Well, that's exactly what Earth's atmosphere does to starlight. Those uneven mixing layers of warm and cool air act just like that wobbly pool of water.
And this brilliantly illustrates exactly what happens. First, light travels perfectly straight from a distant star, right through empty space. But second, as soon as it hits Earth's shifting layers of warm and cool air, the light gets confused. Third, the light begins to bend in random directions. And yep, that's refraction. Sometimes the light bends right towards Sam's eyes, making the star look super bright. But a split second later, the mixing air bends the light away, making the star look dimmer. This constant, super fast bending towards and away from your eyes is exactly what makes that perfectly steady star look like it's twinkling. So, mystery number 1, solved.
Moving on to mystery number 2, escaping a smoky room. Suddenly, Sam magically finds himself inside a smoky room. Flames are flickering and thick gray clouds are filling the air. He tries to stand up, but his eyes instantly sting, his chest burns, and he starts coughing. But when he drops down to his hands and knees, just like a fireman, he makes a vital discovery. The air near the floor actually feels cooler and clearer. He can breathe easier. But why? Well, the fire is heating the air, and hot air always rises up to the ceiling because it becomes lighter than the cooler air around it. As that hot air rises, it drags all the dangerous smoke, ash, and poisonous gases right up with it. Down by the floor, that cooler, heavier air stays put, holding way more oxygen and a lot less smoke.
Now, what's really interesting about this is if you stand up in a fire, the smoke presses around you like a heavy, hot blanket. Because the hot air becomes lighter, it pushes that suffocating blanket right up to the ceiling. So if you ever find yourself in an emergency like this, remember Sam and the firemen. The cooling effect of that heavier air near the ground gives you a much better chance to breathe fresh oxygen and actually see clearly enough to find your way out. Mystery number 2, solved.
Next up, mystery number 3, how ships stay afloat.
All right, so Sam leaves the smoky room, jumps into a pool to cool off, and notices something weird. A heavy bucket feels incredibly light in the water. So he dives into the ocean and finds he can lift a massive rock with total ease. But when he tries to push the rock back down, the ocean pushes it right back up. It's almost like the ocean is holding Sam in its arms. Every time he tries to sink toward the bottom, the water just keeps pushing him back up toward the surface. So here's our next big question. Why do we, and even heavy rocks, weigh less in water? What exactly is this invisible force pushing back against us?
Well, the answer is a fantastic science word, buoyancy. Buoyancy is an upward force created by water that acts completely opposite to your weight. Think of it like this. When gravity pulls you down, buoyancy pushes you up. Imagine jumping on a giant invisible trampoline. When you push down into the trampoline, those springs push you right back up into the air, right? Well, water does the exact same thing. When you push down into the water pushes back up against you.
So the crucial point here is that water basically acts like giant invisible hands pushing you up toward the sky. This upward force of buoyancy acts on absolutely everything you put in the water. It pushes up on a bucket, it pushes up on that heavy rock, and yep, it pushes up on your own body too. which is exactly why you can float on your back on a sunny summer day.
The power of buoyancy is just absolutely incredible. It lifts heavy rocks underwater and makes your body feel lighter. But you want to know the most amazing part? Think about massive, gigantic metal ships floating on the ocean. Even though they are unbelievably heavy and carry tons of cargo, the giant invisible hands of the ocean push up on them with enough buoyant force to completely balance out their weight and keep them from sinking. How cool is that? That is the magic of buoyancy. Mystery number 3, solved.
Which brings us to mystery number 4. Why do we blink?
So Sam is just kicking back, reading his favorite comic book, when his eyes start to feel dry. He blinks and magically shrinks down, smaller than a bug, actually entering his own body to see what's going on. And let's see how this builds. He realizes that when his eyes get dry, his brain sends a lightning-fast signal. The soft inside of his eyelid brushes over the surface of the eye like a gentle windshield wiper. It spreads a thin layer of tears, which are made in these tiny tear glands, evenly across his eye to clean it. But wait, that's not all. Blinking also prevents your eyes from getting strained when you're focusing really hard on a comic book or a screen. Plus, if dust or a super bright light suddenly comes near your face, you blink incredibly fast as a quick defense mechanism to protect your eyes. Our bodies are literally amazing. Mystery number 4, solved.
And now for our final agenda item, mystery number 5, the big science quiz. All right, junior scientists, you've traveled to space, crawled through smoke, dived to the ocean floor, and even shrunk down inside an eye. Now it's time to test what you've learned in our explainer today with a rapid-fire quiz. I'm going to ask you 3 questions. Shout out the answers as fast as you can. You ready? Here we go. Question number 1. Think all the way back to the beginning. When starlight hits Earth's moving layers of warm and cool air, it bends. So what makes a steady star look like it's twinkling? What's the science word for that bending light?
Refraction. If you said refraction, you are exactly right. Those shifting layers of hot and cool air bend the starlight toward and away from our eyes, creating that beautiful twinkle. Great job. Okay, let's go to the next one.
Question number 2. Remember when Sumo was trapped in that smoky room and he saw the brave firemen crawling? The hot, dangerous smoke acts like a heavy blanket that rises to the ceiling. So where's the safest, coolest, most oxygen-rich air hiding?
Near the floor. Excellent work. The cooler, heavier air stays down low near the ground, which is exactly why dropping to your hands and knees gives you the best chance to breathe and see. You're 2 for 2. All right, one last challenge.
Question number 3. We know that things feel lighter underwater because the ocean acts like a giant invisible trampoline, pushing back against you. What is the name of this amazing invisible force that's so powerful it keeps massive, heavy ships afloat?
Buoyancy. You totally nailed it. It's buoyancy that pushes right back against gravity and keeps those huge ships sailing smoothly. Wow, you all are officially top-tier science detectives. We have explored the stars, the ocean, the air, and even our own eyes today. But you know what? Science doesn't stop here. Take a look around your own home right now. What makes the refrigerator cold? How does a light bulb actually glow? What other invisible science mysteries are hiding right there in your house, just waiting for you to solve them? Keep asking why, keep exploring, and I will see you on our next magical adventure.